Hi, everybody. Thanks for joining in today. We are here for our July 20th session on New York JavaSIG. Um, and today is an exciting session. We will be talking about Lambdas and AWS. So before we start off the meeting, I'd like to first, welcome you all and want to make sure that you all are following us on our Twitter feed. So you can see at the right-hand side here, you have our Twitter account, and on the left, you can, follow us on our website as well. So please do subscribe to Twitter and our website, and so that you're always on top of the notifications and you're aware of what are some of our upcoming sessions. Um, and with that, I'd like to hand it off to Jean, who's our trivia host for today.
Hi, everybody. Get your fingers ready. It's time to do some voting. First up, we have a question to find out if this is your first JavaSIG meeting. We want to know whether you've been here before or this is your very first time. The link to the Menti is in the chat, so please give it a shot and vote so we can see what our audience looks like. I'm going to pause for a minute as we all admire the nice hot weather we're having today, and we appreciate that we're in the cool air conditioning, about to hear Mike speak at the Java user group. I know we have people from all over the world. Conveniently, we didn't ask that. We asked whether you've attended before. Okay, our next question is what version of Java you're using. Now, I know that everybody's thinking that, oh, well, we know what everybody's using. It's Java 14, right? We're all using Java 14 in production. And I know that would be silly. But luckily, we have a mix of answers. We have at least 5 people who have been to meetings before, and we have at least 1 person who hasn't been. For versions of Java, I'm starting to see Java 8 come in. Come on, let's have some challengers. Is anybody still on Java 4 in production? That would be really exciting, right? To know that anybody's on a really archaic version of Java. Okay, checking our results. Ooh, we have someone on Java 11, 12, 13, or 14. I like how we put all of those together because you get credit for being on a modern version of Java. Ooh. We also have a bunch of people who put Java 8 in the chat instead of on Menti. Our next question is a trivia question. For the trivia question, we want to know what you think things output. And if you've seen this before, you know that we have 2 different trivia questions that are very similar to each other and exhibit some behavior in Java. Typically, the first one is a baseline to make sure we understand the code and not trying to trick you. And the second one is a nice surprise. Ooh, surprise. Okay, so our first example, remember to click on the Menti, is that we have 2 integers, integer value of 8, set in 2 different variables, and we print out int1 equal int2 using an equal equal and an equals, and we ask you which booleans they output. So let's pause for a moment as everybody thinks about what happens. This exercise isn't very fun if people don't answer. Okay, we've already got split vote. Everybody agrees the second one is true. So we all agree that equals returns true for both of those. We've got 2 wrapper objects here, integer with a capital I. And we have the question of, we have mixed feelings about whether using equal equal will return true. The 2 people who said that it outputs true true are in fact the ones that are right. It does put true true. I'm not going to explain why, because this is a little tricky. And if I explain why, I might give away the answer to the second. So let's take a look at the second one. And remember that I am trying to trick you. That should make it easier to figure out what the answer is supposed to be for the second one. In our second example, we have integer value of 8,000 with an underscore after the 8. So we have good form and readability. And we have 8,000 for the other one. And same thing, what does it print out with equal equal? And what does it print out with equals? So let's go to the Menti and see what happens here. What do we think happens? This one's tricky because we know how the previous one worked. We know it output true true. So it could be true, true, but we know Jean is trying to trick us. So is she trying to trick us that one of those trues is a false? Or is she trying to trick us that it outputs true, true, and the trick is that you shouldn't fall for it and think something is different? We shall check. And we have a split vote again. We have true, false, and false, true. So everybody does in fact believe that I'm trying to trick them as advertised, which means it does not output true, true. The question is, which one is different? Well, the answer is that object caching does not happen for large values. So equal, equal does not in fact return true, but equals does return true. Because with equals, it's looking at the numeric value, but with equal, equal, it's looking at the cached objects. The lesson here is please, please, please don't use equal, equal when comparing objects. It doesn't work, it surprises you, and it gives you this unfortunate behavior that you do not want to see. We're going to do one more poll question. This one's going to be in the chat. If you don't know where the chat is, it's where I just typed hi. It's also where I've been pasting the Menti questions. We want to know, so that Mike can prepare his talk here, what people's experience is with Lambda. So type in the chat what your experience is with Lambda. It could be, I've never used Lambda. I've only read about Lambda. I've played with Lambda, but I've never used it in a real app. Or I'm using Lambda in production. I know lots. Type in which of those best matches you into the chat so we can get a better experience and feel for what the audience contains. As people type into the chat, remember that you don't have to write a novel, just one sentence of where we're going. Ooh, we have a Lambdas in production person already. Exciting. Okay, we have a toy app. We have a mix. I'm at toy app as well. We have someone who uses Python Lambdas in production. You're using the wrong language. This is JavaSIG. We have someone who played with, and we have Lambdas in production. So I think the note of our, oh, and we have people who have never used it and been to meetings. We've had people saw their customers using Lambdas. We have Node.js and Java. So we've got a good mix here. I think the survey says that people fit into all of those buckets, and Mike can't optimize his presentation by assuming anything about the audience, alas. But we got good participation, and if nothing else, that was worth it. Sai?
Thank you, Jean, so much. That was a great trivia. I enjoyed it. So without much ado, let's start off with the most important aspect that we are here for today, is to learn about AWS Lambda. And as rightly you all pointed out in the chat, we're excited about learning more about AWS and Lambda, which in fact Mike introduced to JavaSIG in 2017. So today we are really excited to find out what has changed in the last 3 years. How has AWS evolved and how has Lambda evolved? And one thing that hasn't changed until today is about the cold start. And Mike will definitely speak more about it today in his talk. So with that, I hand it off to Mike. Mike, welcome to JavaSIG, and can you share your screen?
Hello, Sai. Yes, I will try to share my screen. Oh, it says host has disabled screen sharing. Aha. Let me try again. Okay, hopefully everyone can see that. I'm going to assume yes, unless anyone tells me otherwise. So thank you, everybody, from the JavaSIG, Sai and Jean and Barry and Frank for inviting me. It's great to be here. This is my first online presentation during these times. So this is a whole new experience for me, as well as probably for some of you all as well. As Sai mentioned, I spoke to JavaSIG 3.5 years ago, giving an introduction to Java and Lambda, and I did that with my business partner, John Chapin. I'll talk more about that in a second. But I really wanted to have the opportunity to come back and talk about it some more for a couple of reasons. So first of all, excuse me, there we go. So when John and I came 3.5 years ago, we had just started our company called Symphonia. And now, getting on towards 4 years, this is what John and I still do, and helping people out with AWS architecture and DevOps is sort of our day job. And it's been really fun building the company and meeting a whole bunch of people over the last 3.5 years. The other thing that happened was that we wrote a book on AWS Lambda with Java, which is fairly unique as a combination, because there's quite a few people out there that think that you shouldn't use Java and AWS Lambda, and John and I disagree with that, and we disagree with it so much that we spent 2 years writing a book. And so I wanted to come back and talk about why that is, what we think, why we still think that Java is a great fit for Lambda, and even better fit for Lambda than it was 3.5 years ago. And so it's great to be back here. So what I want to chat about tonight, first of all, I will give a very quick introduction to Lambda. I'm sure many of you have used it and may have been here 3.5 years ago or seen the talks that are online. But I'll give a 4-slide intro to Lambda. The two chunky things I want to chat about tonight, one is cold starts, and don't worry if you don't know what they are, because I'll explain them. And the second thing is why I think that Lambda is ready for the enterprise in a way that it hasn't been before. And finally, I'll just wrap up with a couple of slides about what I've learned, a couple of things I've learned over the last 3.5 years. But let's start with an introduction to Lambda. Lambda is a coding environment, and so it wouldn't be the simplest example I could give without doing hello world. And so this is hello world in Java. As you can see, there are no types that we need to extend. There's no interfaces. It's very clean, simple code. There's no life cycle here. And the other thing is that there's no public static void main here. So first of all, what makes this a Lambda is really just the basic type of method signature it has. It is a method that takes an event. And that really is all Lambda is. But because it doesn't have a public static void main, how on earth does this thing run? Well, to understand that, we need to know a little bit about the Lambda runtime environment. So Lambda functions are invoked. We can either call invoke directly on them, or much more common, our Lambda functions are tied to an upstream event source. I'll talk about that a little bit in the next slide. But whatever happens, when our Lambda function is invoked, the way that invoke happens is that we call invoke on the Lambda API, or AWS call invoke on the Lambda API for us. Because Lambda can't be run on your own. You can't download the Lambda runtime and just run it in production. There is a test version, but if you want to run Lambda functions in production, you have to use the AWS Lambda service. And that is the thing that captures the need that we have to invoke a function. When a function is going to be invoked, a whole bunch of things then happen. So Lambda will create a host environment, and that's a Linux environment. Within that, it will, if we're using a Java Lambda, it will instantiate a JVM, Java Virtual Machine. It will then instantiate the Lambda Java runtime, which is effectively Amazon's custom application server. And then that part will instantiate our code, and eventually calling the handler method that I showed you on the last slide. So that's a little bit of the runtime environment of Lambda. How do we use that to build applications? Well, here's a very sort of standard microservice. It doesn't look that different to something that you might build without Lambda. So on the front, we have Amazon's API Gateway service, and this is a configurable backend as a service, as we call it. where we say, hey, we want to run an HTTPS API. We give it a bunch of configuration, and Lambda runs, an AWS, sorry, runs that API gateway for us. One of the options that we have in implementing routes in an API gateway are to tie specific endpoints to Lambda functions. So we can say, hey, if someone calls /events on this particular API, we want that to call a particular Lambda function. And we define that through configuration of the API gateway. And so this is how we can have our API gateway call Lambda functions. Now, once we're in the Lambda function, it's a JVM running on Linux. We can do pretty much whatever we want. And so we might, for example, call out to a database like DynamoDB. When we've got a response from DynamoDB, we then package up whatever we wanted to send back to the user and then send that upstream. And just a couple of other little notes here. The way that API Gateway is going to invoke our Lambda function is it's going to pass a JSON representation of the original HTTP request. And in this case, our Lambda function is actually going to return a JSON response to API Gateway, which is going to be unpacked and turned into an HTTP response. I say in this case because in many cases, Lambda functions are used asynchronously, where they won't return a response. But when you're using Lambda to build an HTTP API, you obviously want to return something to the user. So that's the basic architecture of building a Lambda application. Here is an example of the code that you would implement here for Lambda. So, excuse me. This is basically the entirety of a very, very simple version of an HTTP API that calls DynamoDB. So the first things I want to focus in on here are the method signature and the response, because this is really the only thing that makes this a Lambda function. Everything else here is just code. So as I said before, a Lambda function is a method that takes an event. By convention, we call it handler, but we can call it whatever we want. That's just a configuration. So in this case, we have a handler method that is taking an API gateway request. And that is just a Java object, Java bean representation of the JSON that is going to be sent to our function. And then at the end, we're going to then return what we call here an API gateway response. And this is going to be unpacked into a JSON. It's going to be deserialized into a JSON version of this event that is then sent back to API gateway. And then API gateway will handle all the HTTP-ness for us on our behalf. So these two lines here are really what makes this a Lambda function. Everything else is standard code. So one of the things that, because it's standard code, we will want to do some setup. So you can put this in a constructor or whatever you want. Here, just for brevity's sake, I've got a few member variables that I set up, including a connection to a DynamoDB table. We will typically end up having an instance of a Lambda function called several times in its lifetime. So it's useful to typically cache off things like connections. And then finally, we have the code. And this is just Java code. There's no Lambda libraries here at all. This is just making a call out to DynamoDB based upon some values that we've read out of the original request. And then we are taking the values that we get from DynamoDB, putting that into an API gateway response and sending it back. I'm using DynamoDB here. You can just as easily use a SQL database, but using DynamoDB is quite common when you're building Lambda applications. So why do I like Lambda and why do other people like Lambda? Why have I spent 4+ years building Lambda apps now? So there are a few reasons. First of all, there is less code. So I was able to show you that example of a full HTTP application with not very much code at all. And that's largely because we have this configuration-based integration with upstream services that are also in Amazon Web Services. The next reason is simpler operations. So we're not managing any hosts or runtime environments at all with Lambda. We are defining what our code is, we're defining what our configuration is, and then Amazon are responsible for all of the management of all the hosts. So there's no Kubernetes environments or other Docker environments. That's all on Amazon to manage on our behalf. There's a very efficient pricing model with Lambda in that it's based purely on when our code is executing. And that's down to 100 millisecond level of precision. And what that means is that we are only being charged for our application when it's actually doing anything. So if for 12 hours of a day, our application is just sitting idle, then we're not paying for that. We're only paying when our code is executing. And then finally, Lambda has this really great scaling model where scaling is completely automatic, and it will scale as wide as it needs to handle the load at any one time. And scaling is also highly isolated. And that's because what happens is Lambda automatically provisions a separate environment per event that we need to process. And so the threading model is that there is at most one request per Java virtual machine running at any one time. We can create threads if we want within that, but we're guaranteed that only one event is going to be sent to our Lambda handler, and we won't get another one sent to our Lambda handler in that instance until we've sent the response back. So that is why I like Lambda, is why quite a lot of other people like Lambda. If you like more of this and you want to read more about it, then please see my book. We're actually going to be giving away some copies of the book at the end as well. Okay, so that's the introduction. Let's move on to the first chunky part of the talk, and that is cold starts. So the reason I want to talk about cold starts with you all is that the most common questions that we get asked when we tell people that we are big fans of Lambda and Java, we get the following questions. What about cold starts? But what about cold starts? And yes, but what about those cold starts? Literally 9 questions out of 10 that we get from people when we say that we like Lambda and Java is, but what about cold starts? And it's funny because typically I don't care about cold starts that much for reasons that will be more obvious as I get through this. But everyone else who's never written a Lambda app in production always worries about cold starts. And there's perfectly good reasons why that is. So I want to talk about what cold starts are, why people are worried about them, and a bunch of research I did into to put some more numbers around it. And then finally, I'm also going to say what you can do if cold starts are a problem for you, how you can work around them. And hopefully that will be useful for a bunch of you. To start with though, what is a cold start? So I talked about when earlier on, when Lambda is going to process an event for us, it finds an environment in which to process that event. And oftentimes it's going to need to create an environment in order to process that event. And so a cold start is the extra latency incurred when the Lambda platform needs to spin up a new runtime environment to process a request. So by default, Lambda has a just-in-time model for instantiating environments. It won't create them ahead of time. And so it only creates runtime environments when it needs to. So when is that? In other words, when does a cold start occur? So first of all, whenever our code or our configuration changes, we don't want the old version of our code to run. We want the new version of our code to run. And so we'll see a cold start whenever we update the code or configuration of our Lambda function. Also, if an instance of a Lambda function hasn't done anything for a while, so it processed an event and then it's just sitting around, once it's been sitting around for about an hour, Amazon will kill it off. So they don't keep instances around forever. And this means that if you have an application that's only going to get called once every couple of hours or so, then you'll find that it's going to get a cold start every time you call it. So that's one time. So Lambda kills off instances once they haven't been doing anything for about an hour. The other time that Amazon kills off instances of a Lambda function is once they get to a certain age, even if they are being used. And we find that that's around 6 hours. That's not documented, and Amazon have changed this over the years. But basically, once a previous environment has been alive for about 6 hours, then Amazon are going to kill it off. So that you don't get instances of Lambda that have been around for days and days and days. And so if all of our previous environments have been killed off, then obviously we're going to have to create new ones in order to process events. And then finally, a cold start will happen when we need to scale. So I mentioned before that Lambda guarantees that we don't process more than one event concurrently in any one Lambda instance. And so what that means is if all our Lambda instances are in use and a new event comes in, then Lambda is going to need to scale out and create a new environment in order to process that event. So these are all the occasions that a cold start can happen. So in reality, how often is that? So if you have an application that's processing about 10 requests a second fairly consistently, given a number of other constraints, you can say that basically you're going to get a cold start 0.001% of the time. So 1 in 100,000 events is going to be a cold start. That's for a very, very high throughput application, that's what you're going to be seeing. On the other hand, if you only process one event every couple of hours, then actually you're going to get a cold start 100% of the time. And so how often you get cold starts is very much tied into the throughput of your application. And that's also why cold starts always feel worse at development time. So very often people will try Lambda out for the first time in development. They'll see a cold start on every invocation, and it will scare them a lot. But often, once you put an application into production and put it under production load, it then often doesn't become nearly as much of a problem. Okay, so that's how often cold starts happen and why they occur. How bad are they? Why are people so scared of cold starts? Or in other words, how slow are cold starts? I mean, we're treating the JVM as an ephemeral environment. That can't be great, can it? Well, it's not maybe as bad as you think. So what we find is for Java runtime lambdas, a cold start is at least 400 milliseconds. So I haven't seen a cold start for Java Lambda anything faster than 400 milliseconds. So that's not great, but it's not terrible either. And so that's our baseline. Typically though, for functions with a few libraries, for sort of a standard configuration, it's a good rule of thumb to think about your Java Lambda functions having a cold start of between half a second and a second. That's about typical. You can tune it. Obviously, you can get close to that 400 millisecond time, but between half a second and a second is about typical. It can be a lot worse than that, depending on what you're doing. But this is what I tend to think about. When I say it can be worse depending on what you're doing, and that's because what you actually do with your Java Lambda function, with your Lambda function, can actually impact cold start time a lot. And the things that impact cold start time are really bucketed into two areas. One is application initialization, so what we do in our code during a Lambda function. And the second thing is system configuration and packaging. So how we actually define the setup of our Lambda function and how we package the artifact that contains our code and our libraries. So first of all, on the application initialization side, the things that we can do here to reduce cold start times are things like not using Spring. So some of you will probably have seen a talk that was given here about a month or so ago about Micronaut. And Micronaut is really trying to solve the problem, not just for Lambda, but for lots of ephemeral environments where we're trying to avoid the slow time that comes when you're using a reflection-based framework like Spring or other things like that. And I strongly recommend, even though there are libraries to support it with Lambda, but I strongly recommend you don't use Spring with Lambda if you care about cold start times. And instead, you can hand roll your coding dependencies. So like I did in my earlier example, there was no dependency injection framework at all in that early example. Or if you want to use a more structured dependency injection framework, then use something like Micronaut. Another thing is that if you are loading state when your application comes up, then consider lazily loading state per request. So that's all I'm going to talk about around application initialization. That's really a programming thing, and it's not specific to Lambda, but those are things to be aware of. What I want to talk about mostly here is the things that are specific to Lambda. And so this is configuration and packaging. Now, I knew that we can reduce our cold starts via configuration and how we package the function artifact that we put our code into. But I was actually really interested in how much of an impact we could have. And so about 2 or 3 months ago, I started doing some research into cold start times because since it's a question that I always get asked, I wanted to be able to actually give some numbers to people. And so over the last couple of months, actually the beginning of May, I started running some analysis on cold start times. And the way this worked is that I deployed a number of Lambdas with a very, very simple piece of code, but a whole bunch of different combinations of configuration. And I deployed those Lambdas around the world in lots of Amazon regions. And then I had a very, very simple test harness, which was actually another Lambda function, but it didn't need to be, calling that test harness from outside. So this was a round trip latency test from calling outside of Lambda, calling into the Lambda service in our function, and then timing how long it took to get a response back. If you want to see the actual full framework for this, it's all the code for this is available open source on our GitHub repo. So what I want to do is talk about some of the things that I found and some of the things that I learned and a couple of surprises that happened during this analysis. And the other thing I want to mention is I'm going to show you some graphs. For those of you who might be able to see this, I did this over a course of 7 weeks. So basically the start time on this was the beginning of May and the end of this was the end of June. So first of all, I wanted to do a control test. I wanted to see, is there a difference between warm starts and cold starts? So warm starts is where we call a Lambda function and that Lambda function has already been instantiated. And sure enough, yes, there is a big difference between warm starts and cold starts. Now, the absolute number here for cold starts is not very useful because I'm just averaging across a whole bunch of configurations. But what I can tell you is that the warm starts were extremely stable around 19 milliseconds. And that time is basically the time for one Lambda to call another Lambda in the same region within AWS. That round trip time is about 19 milliseconds. And so what that tells us is a couple of things. One is, yes, cold starts are real, not a shocker. And the second thing is that these times, if you want the absolute extra delay caused by cold start, then basically just take 19 milliseconds off of these numbers. But these numbers will be significantly bigger than 19 milliseconds. So I'm just going to use the cold start times as basically the cold start latency. So let's go and look at some different cold start numbers. So the first thing I wanted to check was how Lambda cold starts changed according to the memory that we gave it, according to the Java version, and according to the package size. So let me explain these three things a little bit more. When you define the configuration for your Lambda function, you can tell it how much memory it has. And that can be anywhere up to 3 gigabytes. The important thing to know about that, however, is that when you set the memory size, you're not just setting how much memory it has, you're also setting the proportion of a CPU core it has. So 1.7 gigabytes Lambda configuration is a full CPU core. Less than that is a linear proportion of a CPU core. More than that, and you start getting a proportion of a second CPU core. So 512 megabytes is basically you're getting 1/3 of a CPU core. 3 gigabytes, you're getting nearly 2 full cores of a CPU core. And this is important because obviously when we're starting a Java application, how much CPU we have is going to impact cold starts also, we would think. JVM version, when I talked here 3.5 years ago, the only thing that we had was Java 8. We do now have Java 11. I fully expect that Amazon are going to give us the LTS versions of Java fairly quickly. There was a little bit of a delay in getting Java 11 out, but that's because they were changing a whole bunch of other things under the covers. But I expect that Amazon will follow the LTS releases pretty closely. For what it's worth, Amazon used Java a lot in their own systems. So Java is not a second-class citizen for them. Java is absolutely a core part of how they work internally. So they're very used to working with Java. And then finally, the package size. And what I mean by this is, what is the size of the artifact that we upload to the Lambda service that contains our code? And that also contains all of our libraries. And it turns out that package size has by far the biggest impact of these three things anyway on our cold start times. So you'll see here in this graph, we've got a clump of lines toward the bottom and a clump of lines at the top. Those ones at the bottom are a very, very small artifact. Basically, it's a single, basically hello world. There's no libraries, there's no other code. The clump of lines at the top are lots of libraries. Basically, I was trying to max out the package size. The biggest Lambda artifact that you can have is 50 megabytes compressed. And so I was trying to put as many libraries as I could in there. And that's what you see at the top. So package size has a huge impact on cold start time. And that's not really surprising because Java when the JVM starts up, it needs to load all of those classes. So one of the other things I mentioned, though, is I was interested in looking at the difference between Java 8 and Java 11, considering those are two supported runtimes. And so can I categorically say that one is faster than the other? The problem is no. The graph on the left, this is using a very high performance Lambda configuration and a very small artifact. And here, Java 11 is significantly faster than Java 8. So we're seeing a 400 millisecond startup for Java 11. We're seeing about 570 milliseconds for Java 8. And so that's quite a big difference, like, percentage-wise, that's 30% difference or something like that. However, the graph on the right-hand side is an artifact with lots of libraries in it and only half a gigabyte of memory. And here you can see that they're just completely overlapping and there's no way of telling the difference. So if you have a nice and lean Java Lambda function, you're probably going to get a cold start improvement using Java 11. But otherwise, it's going to be kind of hard to tell. So whether you use Java 8 or Java 11, it might not impact cold starts that much for you. One surprise that I had from this that I sort of wanted to test for, so I wasn't too surprised, but I was kind of surprised as well, was it turns out that Lambda performs differently according to what region you're in. So for those of you that don't know, the way that Amazon divides up its platform around the world is it creates it's about 22 different regions around the world. And these are clusters of data centers, basically. So there's 4 main regions in the US, a bunch in Europe, a bunch all over the place. And what I found was that even though these things functionally are the same in terms of the capabilities that they have for Java, I was finding that the cold start times were different according to the region. The most drastic difference was between these two regions. And the fast region here is AP South 1, which is Mumbai in India. And the slowest region here is EU Central 1, which is Frankfurt in Germany. And the other thing to notice here is I tested this over nearly 2 months, and you can see that there is a consistent difference in time here between these two regions over this time period. Now, I don't know for certain what causes this. I have some theories. Certainly Amazon haven't said anything. But it is worth knowing if you are really tight on your cold start times, that what region you deploy to could have an impact. The other thing similarly here to notice is that volatility of cold starts can also change a lot. And this actually was a surprise to me as well. So here you can see the lower cold start time is our small function artifact. And not only is the cold start time less, but the percentage volatility is significantly smaller than that large artifact time. So for the small artifact, we're about 550 milliseconds plus or minus 25 milliseconds or so. For the large artifact, we're at 1.2 seconds plus or minus 200 milliseconds. And obviously that's a much, much bigger difference percentage-wise on a volatility point of view. Now, 2 things to know about that, 2 things we can take from that. One is, you're going to see volatile cold starts in your behavior, especially if you have these larger artifact lambdas. But the second thing is, if you're doing your own benchmark testing, you may want to test over a period of time to make sure that you're getting the whole range of possible answers. The final graph here is, so people say, shouldn't use Java and Lambda because Java has slower cold starts. Does Java have slower cold starts? Yes, it does. That's not at all surprising. So here I have Java 11 is the blue line, Java 8 is the orange line, and then Python 3.8 is the gray line. So we're seeing that for a similar type of application, Python has about half the cold start time as Java. Is that a problem? Maybe, maybe not. And I'll get into that a little bit, but that is true, but not surprisingly, Java does have slower cold starts than Python. And similarly for Node and Go and all those kind of things. So that was really interesting. If you want to see more of this, I did collect some more data, and this is all available online. Actually, I'll have a link for this in a couple of slides' time. So, given all of this, should you care about cold starts? Typically, no. Most teams I've worked with, when they are worried about cold starts in development, they put their application in production, and it turns out that it's not a problem. And that's because lambdas in production are being invoked frequently enough that you're not getting a cold start very often. So basically, they're amortizing that cold start time over tens of thousands or hundreds of thousands of invocations. And especially if you keep your package size small and you're using a reasonable amount of memory, don't use 128 megabytes of memory if you're using Java and Lambda. It's going to be horrible. And if you're not using something like Spring, then I think that you're fine in most production usages of Lambda. But I'm not going to leave it there. If you do care, if you do need to care about your cold starts, what can you do? Well, there's a few things that you can do that are fairly simple in comparison. You can trim your library dependencies. This is kind of weird in how we used to like building these massive Java artifacts. But if you actually just bring your library dependencies down to the bare minimum, that is going to help a lot. And that's part of this package size thing that I was talking about before. Use Java 11 if you can. Obviously, that's not from the results that we've seen. That's not going to help all the time. But there are many situations where using Java 11, it turns out, is going to have a faster cold start time than Java 8. Increase memory size to maximum. Get all the CPU and memory that you can. Reduce your startup logic. Don't use a heavyweight reflective framework. Roll your own constructor dependencies or use something like Micronaut instead. And then maybe consider using alternative regions based on some testing. That's kind of a nuanced thing, but if you're being really tight about your cold starts, maybe that. But if all else fails, there's actually some escape hatches. And this is where you can bring out the big guns. If cold starts are, you're like, no, we can't do it, cold starts, there are some big guns now that you can use. First of all, Lambda now has a feature called provisioned concurrency. What provisioned concurrency lets you do is say, hey, I always want to have at least n instances of my Lambda already started. And if n is larger than the number of invocations or number of concurrent Lambdas that you need, you are guaranteed that you are never going to get a cold start. Great, we should just do this all the time, right? Maybe not. A couple of reasons why not. First of all, it costs extra. And it actually breaks that request-based cost model because you're always paying for provision concurrency, even if your Lambda functions are not getting executed. And you also have to think about scaling what that number of provision concurrent instances are. And so you have to start thinking about manually scaling, which is annoying. The other reason that provision concurrency is, at the moment, is that I found in my testing that it significantly slowed down deployment. Anywhere between an extra 90 seconds and an extra 4.5 minutes, depending on how big your provision concurrency was. However, if cost is not a problem and your deployment speed extras are not a problem, you can literally buy your way out of the cold start problem now. And that's something that just didn't exist until late last year. Other options you have, lots of you here, it's a JavaSIG, are going to like things like GraalVM. You can now run GraalVM on Lambda. And the reason for that is that a couple of years ago, Amazon started letting people run their own custom runtimes on top of the Linux virtual environment that is part of the Lambda service. And so there's a lot more work here. You're not getting some of the extra handholding that Lambda normally gives you. But if you want, you can compile your application using Graal and then run a custom runtime using Graal. I haven't done it yet. It's on my to-do list of experiments that I'd love to do over the next couple of months, but you can do it. And finally, if all else fails, yes, use a different language. Hopefully you won't have to. Hopefully you'll be able to use, if you want to use Java, everything that I've told you here will allow you to use Java, and that cold starts aren't the problem. But occasionally, even I write Lambdas in things that aren't Java. Sometimes I'll just like spin up a JavaScript or a Python Lambda. But normally for heavy throughput, Java applications, Lambda works just great. There's a lot more detail on the research I did online. My slides here are actually online. I just put them online just before the talk. If you go to Twitter, my Twitter handle is here on the slides, Mike B. Roberts. There is a link to my slides, and then you can see where all this research is. Please go take a look at the source code. Hopefully it'll be interesting for some of you. All right, that's enough about cold starts. Hopefully I've satisfied a few of you that might be one of those people said, but what about cold starts? But let's talk about some other things. So, as I mentioned at the beginning, I was here chatting 3.5 years ago. At that point, my business partner, John, and I had already been using Lambda and Java in production for about a year or so for real size production applications. But I'd be lying if I said that it was all rainbows and unicorns at that time. There were a whole bunch of things that we had to work around, and I couldn't necessarily recommend it to everybody, certainly enterprises. I think now Lambda is largely enterprise ready. Amazon have done a lot of work on Lambda and the surrounding ecosystem. And so I think if you looked at it 2 years ago or 3 years ago and went, oh, it doesn't do X, Y, or Z, it's really worth relooking at it because a lot has changed. And I want to talk about that in this section. So some particular concerns I had about Lambda were that it had really slow cold starts for VPCs, and I'll get onto this in a moment. There was the nice thing about Lambda is it scales really easily. The terrible thing about Lambda is it scales really easily because that can have a really bad impact on downstream systems. The tooling was horribly immature 3.5 years ago. The serverless framework was an open source thing that helped a bit, but Amazon's own tooling was not great. Part of that was that the distributed tracing and observability story was pretty much non-existent. And when you're suddenly taking your applications and converting that into 50 different Lambda functions, what you really need is a distributed tracing tool. And that didn't really exist 3.5 years ago. CloudWatch Logs was great for capturing logs. It was terrible for analyzing logs. And there wasn't really a good story for running longer running processes. Basically, if you needed to do anything that was going to take longer than 5 minutes, you had to build a traditional application, and there was nothing really to help. But the good news is that all of those things have been fixed, or at the very least significantly improved. And I'm not joking, they really, really have been. And I'm going to go through all of them here and sort of show what upgrades have occurred to Lambda, but also just as importantly, the surrounding ecosystem that Amazon provide. So let me go through some of these. First of all, on the basics, we now have more runtimes. So we have Java 11 that came out last year, but we also have many other languages. So if you don't want to program in Java, but you do want to program in Rust or Go or Ruby, you can now do that. But even better for the enterprise is that Lambda now supports these custom runtimes that I mentioned before. And so you now have the capability, if you are a large organization and you don't want to use Lambda, you want to use, say, Java 14, but Java 14 is not supported yet by Amazon natively. You can have a platform team that produces a custom runtime and enables that to be used by the entire organization. Or maybe you want a runtime that has a particular security lockdown. You can now do that. And that is just provided by one team in the organization. And then the whole rest of the enterprise can then use that custom runtime. That's a capability that just didn't exist before and is really, really interesting for large enterprises. We get 3 GB memory now. We used to get 1.5. We get 2 cores of CPU pretty much. We used to only get 1. And maximum timeout got an increase from 5 minutes to 15 minutes. There have been a lot of cold start improvements. If I'd run that analysis that I showed you 2 or 3 years ago, I would have added in a couple of extra configuration flags, and I would have seen some times that would have been horrific. The biggest one is that the use of VPCs no longer impacts cold starts. So for those of you who don't know what VPCs are, they're basically a way of having a private networking space within Amazon. And this is sort of, so for example, if you want to connect to a database that is private, so a SQL database that's private, you're going to need to use a VPC to do that. Until, I think it was about a year or so ago, maybe a year and a half or so ago, if you were using VPCs and Lambda, every cold start would have anything between an extra second and an extra 10 seconds of latency because of the VPC, which was a real problem. This has gone away entirely. VPCs do not impact cold start times at all anymore. Amazon completely changed how VPCs are implemented with Lambda. And this is huge for companies that want to be using VPC resources. Cold start times overall have improved because of just underlying infrastructure changes by Amazon. And then to sort of reiterate what I said in one of the previous slides, you now have an escape hatch, especially if you're a large enterprise with a lot of money. You have the ability to pay your way out of the cold start problem by using provisioned concurrency. Scaling control. I talked about how Lambda scaling is great and terrible at the same time. It's terrible because you can easily destroy a downstream database if you're not careful. One of the features that came out pretty soon after I gave my last talk, actually, so about 2.5 years ago, was Amazon introduced a feature called reserved concurrency. And this allows you to set what the maximum concurrency is for a particular Lambda function. So if you don't want a particular Lambda function to scale any more than 5 wide, you just set a flag on it saying reserved concurrency is 5. And then Amazon guarantees that it will never scale out wider than 5. This is a really useful feature as a sort of a safety blanket. I wrote a bit more about this when it came out, but this to me was a very important feature for enterprises as a safety factor. Onto the tooling side, Amazon have made it easier to deploy Lambda applications by creating a thing called the Serverless Application Model, or SAM. There's 2 parts to SAM. One is a template that's part of CloudFormation that makes it a lot more succinct to define serverless resources within CloudFormation, which is Amazon's infrastructure as code tool. So this here is the entire deployment configuration for a Hello World application, for that Hello World function that I showed before, in fact. It could probably be a little more succinct still, but it's a lot better than it used to be. Especially if you combine this with another part to SAM, which is the SAM CLI, the command line interface. They've done a great job of really making the command line tooling very simple. So now all you need to do is run SAM deploy, and it will do a whole bunch of stuff for you. And so this makes deploying applications, especially from a development environment, a lot easier to do. Moving on, I said before that the distributed tracing story 3 years ago was non-existent. That has largely been solved. Amazon came up with a service called Xray, which when it first came out, I wasn't sure about, but it's had a lot of development over the last 2 or 3 years. Actually now is a really good basic distributed tracing application. If you really want, you can still use something like Honeycomb, and that's going to give you more. That's a third-party service. But Xray is a really solid first-party service that very easy to add to your Lambda functions. I very strongly recommend that if you're building Lambda apps in production, you investigate using Xray. And similarly, on the logging side, Amazon came along with a new aspect to CloudWatch Logs called CloudWatch Logs Insights, which gives you a much better interface onto interrogating your log files. Kind of a little bit like Splunk, but for CloudWatch Logs. But the good thing is it's just there in your Amazon console. So if you're already using AWS, you just have this available. So again, if you're using CloudWatch Logs, definitely recommend going and checking out CloudWatch Logs Insights. We also have new integrations that make Lambda more exciting for enterprises. One of the big ones was SQS. SQS is one of Amazon's original services. It's their message queue, their basic message queuing service. Lambda got integration with this very late for various implementation reasons, but it now exists. And so if you're using SQS or you want to build message queue based applications with Java, you now have very tight integration between Lambda and SQS, which is great. Just a few weeks ago, Amazon announced EFS support for Lambda. So EFS is Amazon's implementation of NFS. Yes, NFS, the thing that might be older than me, I'm not sure, but I certainly was using it 25 years ago. But Lambda have this thing called EFS, which is a highly tuned version of NFS to run on AWS. They've introduced this Lambda support for it, where basically you can have a shared file system for all the instances of a particular Lambda function. It's only been out a few weeks, so I'm still not sure about this, but it is there. It's certainly worth looking at. And then finally, in this world, a lot of people were also concerned in the past about not having a real connection pool for talking to SQL databases from Lambda. And so Amazon introduced a thing called RDS proxy, which is a very low latency proxy to communicate with their RDS family of SQL Server databases, or SQL databases rather. And effectively, it's connection pool as a service. So yes, you still can't have the connection pool in Lambda necessarily if you're going to be scaling very wide, but RDS will do that for you, at least in terms of not overwhelming your downstream database. Now, apart from Lambda apps themselves, a lot has happened outside of Lambda in the bigger scheme of building serverless applications on Amazon. And one of the ones that I'm most excited about is a service they have called step functions. And this is great if you are building workflow applications or applications that are going to take longer than 15 minutes. So as I said before, it used to be that if you couldn't do something within the Lambda timeout, you needed to build a regular traditional application. Step functions in a lot of cases now sort of solves that as an in-between case. A lot of people use step functions for operations work, but it does also work quite well in many application circumstances as well. And it's another of those Amazon services which has had lots and lots of updates over the last couple of years. So it's good to see services that are getting constant improvements. There is now a version of Amazon's Aurora database called Serverless Aurora. So if you want a SQL database but don't want to worry about hosts and instances and cluster sizes, that's what Serverless Aurora does for you. And now there is even serverless Spark. So if you are writing Spark to do ETL transforms, so Hadoop type stuff, AWS Glue is now a service that will do a few things, but one of the things it will do is run your ETL jobs for you without you having to manage your own EMR clusters. I've used this with 3 clients this year already. So this is really, really great stuff. So hopefully from that, what you can learn is that a whole bunch of blog entries that I and other people may have written 2 or 3 years ago are completely out of date now. And so if you don't use Lambda or you haven't used Lambda because of concerns around its capabilities, it might well be worth you taking another look. All right, I want to close out with just a few little lessons that I've learned over the last few years. Not all of them, but just a few that some of you might be interested in. So one of the things I've always been interested in around serverless is that serverless is not just Lambda and functions. It's also all of these other services that act in a serverless way. So where you don't have to worry about the operations and you don't have to worry about scaling and all those kind of things. Those things are serverless as well. What we've really sort of come to understand over the last few years is building applications that use a lot of serverless services together work really well. So maybe you're building an application that uses Dynamo and API Gateway and Lambda and S3 and SNS. These are all serverless Amazon services. If you combine the power of these into building sort of one bigger holistic application, it's really powerful and it really reduces the amount of work that you need to do, reducing the time of market, reducing the time to market to produce a new application, that kind of thing. So one call out I'd say there is that if you're learning Lambda, then actually it's going to be even more important that you learn AWS as a whole. Now, not all of the services, because the services on there about managing satellite communications, which most of us will never need, but there might be 30 or so services over there that you would use over a 2-year time span. So it's worth knowing the kind of services that exist in the AWS world. I mentioned before, I think that serverless big data is the next big thing. Now, I am not going to lie, Google were doing this first. So those of you that are Google fans out there can be like, yep, Google got there before Amazon. But Amazon now have a whole bunch of really compelling big data services where you don't need to manage big EMR clusters or big Redshift databases or that kind of thing. You can do a lot of stuff now in the big data realm by using the ephemeral resources that come along with serverless ways of thinking. AWS Glue, I mentioned already. AWS Athena is how you can query over vast amounts of data in S3 just by running a SQL command, and various other aspects besides. And finally, even if you can't use Lambda, and I'm not going to try and persuade all of you, even if you can't use Lambda, one thing I'd recommend is that for your container-based workloads, start trying to think about them more serverlessly. So Amazon now have a serverless-ish container system called Fargate, and you can build your applications using Fargate. Now, you can have a container that's just hanging out for weeks at a time, but I really encourage you to think about how can you take your container applications and make them more event-driven, make them more ephemeral, because eventually it might make sense to move some of that workload to Lambda, or at least gain from all of the other aspects of building serverlessly, like not having to worry about running hosts for a long period of time, being able to closely integrate a whole bunch of other services. So even if you're not using Lambda, try and think about using container-based systems in a more serverless way. And thank you very much. Hope some of you are still there listening.
Yes, we have lots of questions for you. First thing is we need to do a commercial for your book.
Yes. Oh, I should stop my share.
I will be posting the link to win a copy of the book during the Q&A. So watch the chat for the link to win the book. Also, we have a bunch of questions for you. It would be hard to ask what about cold starts, but I feel like that's been covered ad nauseum. So we do have a few questions about cold starts, but they're not what about cold starts. They're more specific, so people are more creative in their questions.
Great.
The first one was about cached references. Does AWS keep instances of Java Lambdas around to reuse them? And if so, for how long?
Yes, it does. And that was to the point where I mentioned the 6 hours thing. As long as your Lambda instance is getting called within an hour, then AWS will reuse that instance for up to about 6 hours. So yes, it will. So you can cache stuff in memory. You can cache stuff on local disk. You don't get much of it, but yes, you can absolutely do that.
Do you get cold starts with provision concurrency? Not at all, or just less than you would without it?
Not at all.
Okay. Is Python slower after cold starts compared to Java?
Sorry?
Is Python slower after the cold start compared to Java? So pretend Java had no cold starts. What happens after
that? Let's go with probably. That's another. I actually want to do that. I was about to do that as my next research thing, and then I got another client, so I've been busy the last couple of weeks. I want to actually do some benchmarking of the different languages. My strong suspicion is that JavaScript and Python will be slower than Java for big chunky processing. And because Lambda has a 100 millisecond pricing model, it might be that Java is even cheaper than those other things. So yes, I would guess so, but I don't have the numbers to prove it.
I don't remember my source, but one of the presenters said that at a conference I was at some point within the last year. And it makes sense because Java's compiled. So once you can get it going, things do go faster.
Oh yeah, it can crank.
All right, so that's it about cold starts. Now we have some other questions that you might find more interesting. Do you recommend any framework to work with Lambda functions independent of the target platform? So like regardless of whether you're using AWS or Google or whatever else.
Oh, interesting. Not really. And the reason why is that, and this is a sort of point to my holistic serverless thing, Lambda by itself is actually not that interesting, despite the fact I wrote a book about it. When Lambda is interesting if you integrate it with all the other AWS services. And so if you're abstracting out all those AWS services, you're not really gaining as much value. So no.
Okay. Do you recommend Spring Boot and Lambda together for a simple REST API app? And if so, is there a worry that the throughput is so low that you're back to the cold start problem?
I mean, and this is the thing, if you have a high enough throughput that you're not getting many cold starts and you're really, really comfortable with Spring Boot, use Spring Boot, check out the cold starts. The thing I'd say is that Spring, was really set up for long-lived applications. It was about starting an application server. You're not running an application server when you're building a Lambda app. You're just writing a little bit of code that's going to process an event. And so it's worth, I would argue, just trying an experiment of not using Spring Boot, because even from a functional point of view, it wasn't really built to solve the same problem.
Okay. What JVM does AWS use for Lambdas?
They use Corretto, which is their open source version based upon OpenJDK. And they have versions of that for Java 8 and Java 11. It's completely open source. They've sorted out all the licensing, so you don't need to worry about it. You can download your own versions of Corretto and run them without fear of running licenses, but that's what they run.
Okay, cool. Note to the audience, we're down to about 5 questions left. So if you have a question, this would be an excellent time to ask it. Also, Mike, you got some compliments on the posters in the chat. Do you have any thoughts on using Drop Wizard in a Lambda?
Oh, there's a name I haven't heard for a while. If I remember rightly, Drop Wizard is another of those sort of Spring Boot type things. So I'd probably err away from it. But it's been 8 years since, or 7 years since I looked at Drop Wizard, so I can't speak with authority on that.
Okay. The next 3 questions are more of statements, but I'm going to say them and I want to see your thoughts or reaction to it. They're things that people stated in the audience, but you're an expert and not everyone in the audience is, so this is a good sanity check. It would be nice to mention SQS pollers for Lambda and empty receives. Do you agree?
And empty receives?
Yeah.
Huh, I don't know. I don't know what that is. I don't know if the person that said that has looked at the newer SQS integration or not. I wouldn't call myself an SQS expert. I've done a couple of basic things with it, but I was looking into a bunch of stuff for a client recently around the capabilities that SQS and Lambda have. So they added some more because they added FIFO support relatively recently. So I don't know what empty receives means.
Okay. Spring relies heavily on reflection. You can, assuming people haven't followed your advice to stop using Spring for this, you can use GraalVM, but it won't have the same benefit as Micronaut or Quarkus. Do you agree?
Well, GraalVM's a whole thing. I mean, if you're using GraalVM, then you have to manage your own runtime, and that's a whole bunch of extra work. I'm not saying don't do it, but I'm saying that is, you've really got to have a cold start problem if you want to use GraalVM.
Okay.
So that's solving one problem. The Spring and Micronaut is it's trying to solve a similar problem in a very different way.
Okay. The next statement that I'm making a question is SAM also allows you to test applications with a local Docker container with a mocked API gateway. Pretty useful. Thoughts?
Yeah, so there's a whole chapter in our book about testing, and I actually did a podcast about a month ago where we really got into this subject. So if you're interested in my opinions on this, go check out my blog.symphonia.io, and I link to the podcast.
Okay, cool.
The basic thing on that is that we are a bit contrarian in the Lambda world in that we don't actually like using SAM local for testing. We like using it for experimentation, but we think if you're testing, you should be writing unit tests that run really quickly within process, or running integration tests where your Lambda is deployed to the cloud.
We're down to the last 2 questions. If you have a question, get it in fast. You mentioned about workflows. Have you seen using a BPM tool, and which one has been better with Lambdas, Camunda or Activity?
I haven't. Oh, hang on. I might have seen someone using Airflow. I can't remember. I haven't. I guess step functions is possibly Amazon's version of that. It's very lightweight. It doesn't have the full external service integration that a lot of BPM tools do have, but you could easily plug that in. It's not as powerful as some other Microsoft tools even, but for basic workflow, it's pretty solid.
Okay. Is there any way to do local development and execution?
Yes, and that's to the other point. You can run, there is an environment where you can run SAM locally. Again, I want to emphasize that a couple of things. One is Java Lambda Code, or Lambda Code is just code. There's no magic, there's no app server there. It's literally just code. The other thing is those local environments aren't always going to act 100% the same way as a production environment.
That is true. And we're nearing the end here. I hope that the last question is an easy question, but we shall see, or second to last question. Do you have any recommendations on the optimal maximum that you set your Lambda timeout to?
Oh, that's a really great question. So there are people that have written things about this, and I haven't, but my basic rule of thumb is set it to a number that it should never get to. So for example, if you're doing something that is like, it should be taking half a second, you don't want to set that timeout to be 15 minutes, which is the maximum, because you could be paying far too much. You should be setting the timeout to like 5 seconds or something. Another great example is if you're using Lambda and API Gateway, there is no point having your timeout set to anything more than 30 seconds because API Gateway will time out the request after 29 seconds anyway. So there's a little bit about what's the external system doing and what should it always be doing. So there's nothing particularly scientific about that.
And we've got a follow-up question on that, which is, in your example, the Lambda was very short. Is that what you recommend as a good runtime for a Lambda, or is like a 5-minute Lambda or a 10-minute Lambda also okay?
You know, there's reasons that Amazon updated the maximum timeout to 15 minutes. I typically try to keep my Lambdas short. If you're doing something that isn't going to run that frequently, and you know it's absolutely going to run in 7 minutes, it's never going to take 15, then sure, why not? I would be, if I was doing something where it was processing 10 million events a day and it was a 7-minute thing, I might think about how I could break that out, because that starts getting expensive at that point because you're paying per 100 milliseconds.
Okay, cool. That was the last real question, but I got to ask one more. But what about cold starts? Right?
Hey, Gene. Hey, Mike. That was a great talk, and thanks so much for that. For the detailed question answer session, Gene. That was amazing. So now let's get into an amazing raffle session. So thanks to Mike and O'Reilly here today, we are raffling off his new book that just got published in 2020. So for all of you on the chat today, Gene, can you help paste the link on the YouTube chat?
Yes, I've actually pasted it twice during the Q&A, and I'll paste it one more time in case anyone managed to miss it.
Awesome. So this is a time, folks, for you to go in and share your name and email. So lucky winners, you will be contacted and you will get a chance to win this book. Thanks to Mike and O'Reilly for helping us today. So let's probably wait for a minute here while everyone fills in their name.
Sai, do people have to fill it in right now, or can they fill it out tomorrow? What's the deadline?
I would suggest, to fill it out by latest tonight, so that tomorrow we can finalize it and then we can pick the winners.
So if I fill it out tomorrow, I won't win because it'll be too late.
That is true. So I think we can keep it open until like 9 p.m. tonight, if by any chance people miss it right now. So while you're all filling that up, I really like to thank Mike today for an amazing talk. Thank you for going in depth into AWS and also sharing your learning from what happened over this past 3 years. This is really cool to hear how the entire landscape has evolved, and it's kind of, I think this is probably the first time I'm seeing it at JavaSIG, where you came back, the speaker has come back with his own findings of what has happened over the past few years, and has given us an in-depth analysis of how how AWS and Lambda have evolved together, and what are some of the new things to look forward to. So with that note, I'd really like to thank everyone for joining today and asking great and intuitive questions. Next, we would watch out the space to hear about upcoming talk by Ray Zhang. This is on August 12th. Subscribe to our Twitter channel, or you can get email notifications through javasig.com. And you should soon hear from us on what is upcoming. So I just want to check if everyone got it in, and are there more? Do you need more time? If so, you can have this raffle open until 9 p.m. tonight. Please make sure you finish it off before that, and so that tomorrow we can identify the winners. With that, I'd like to thank everyone who joined today. Thank you, Gene, for running the Q&A and the trivia sessions. Thank you, Frank. Thank you, Rodrigo, Barry, everyone. Mike, thanks once.